Alright guys, so today we are going to do something called empirical formula. So empirical formula is kind of the ratio of atoms in our molecule. So we're finding the ratio of atoms based on weights of what's in our molecule. So there's two types. There's empirical formula, which is the ratio one. Then there's also molecular formula, and that is based off of how much weight we actually have in our molecule that we're working with. So we're going to focus on empirical today. We'll do molecular on Monday. But in order to find empirical, you need to get your substances to grams. So we get our substances to grams. So in problems 1, 2, 6, and 7, they already have grams for you. So that step, it just kind of takes out a step. So I'm going to do number 3 for you guys as an example. And what this will be, and the reason I'm doing number 3 is just so how you can get percents to grams. And it's actually really easy because it doesn't give us how much of it we actually have or how much like should be. So what we can do is just make assumptions. And when you make assumptions, I want to always go with the easiest assumption I can make. So when we're dealing with percents, they add up to 100%. So to make my life easy, I'm going to just say I'm starting with 100 grams. So if I start with 100 grams of this molecule, I know that I would have 36 point, let me write it up here. I would have 36.48 grams of sodium, 25.41 grams of sulfur, and 38.11 grams of oxygen. Because again, since it adds up to 100, that percent basically just tells me how many grams I have. So I want to assume if you want to do 50, you can. There's just more math involved. So I always suggest doing 100 grams, or assuming you have 100 grams of yourself when you have percents, so you can do percents very easily. All right. Sorry about that, guys. So to find our empirical formula, we first need to figure out how many moles of each thing do we have. I know I'm bringing back the moles thing, but again, stoichiometry, this one's a little easier version of it, or there's not as many steps. So I want to find the moles of sodium we have. So I start with 36.48 grams of sodium. Ooh, and I have grams of sodium on the bottom, and I want to get to moles of sodium. And it's that. Remember, when you have moles over gram, you're going to do your molar mass, which in my case is 22.99. 22.99. And remember, whenever it's not moles over moles, it's always going to be 1. So I come up with that, and I get, I actually need a calculator for it. 36.48 divided by 22.99. I get 1.59. 1.59. Alright, so that's my moles of sodium. I'm just going to put an Na next to it so we know. Next, I'm going to do my moles of sulfur. So I got 25.41 grams. Ooh, I got 1 on top. Then for sulfur, 32.06, I believe. Yeah, 32.07. So I'll always round to 2 decimal places, just so we're on the same page. So this is moles, S. Sorry, I'm not labeling bad. Don't be like me. Don't do bad habits. So I get 25.41 divided by 32.07. So again, all I'm doing is trying to find the moles. So that's my moles of S, moles of Na. Alright, and finally, I need my moles of oxygen, so I got 38.11 grams. And then oxygen, we all know, is 16 grams and 1. So again, got it from periodic table. Oxygen is 15.99, so it's 16. So I get 38.11 divided by 16, and I get 2.38. All right, so that was step 1. So, or I guess step 2. So you find the grams. After you find the grams, you make your grams into moles. Then for the next step, you want to find the least moles, so the lowest amount of moles. For our case, it's going to be sulfur. And you're going to divide all your moles by that number. So I'm going to divide sulfur by 0.79. 0.79, not 6. So 0.79. I'm going to divide the sodium by 0.79. And I'm going to divide the oxygen by 0.79. This is going to be 2. Oh, sorry, that should just be O. Alright. So, we always have one that's very easy to come up with, because anything divided by itself is going to be 1. Next we have our sodium. We have 1.59 divided by 0.79, and we get 2. So for these you want to round to whole numbers unless you get 0.5 or something. Alright, so you want to round to whole numbers unless you get 0.5 or something. Let me get that moles over too. Alright, then finally our oxygen is 2.38 divided by 0.79. And I get 3. So now that I have those numbers, I can write my empirical formula. And you always base it on kind of the heaviest, or the ones to the left, then the heaviest. So for my answer, I'm going to do sodium first, Na, and that's going to be 2, because I have a 2. So these become my subscripts. So I have Na, I have S, and then I have 3. And if you look, you can see on this one, because it's kind of a normal ionic 1, that our empirical formula is sodium sulfate, Na2SO3, because our sulfites, my bad. So that's how you do those. The one thing, let's say instead of these numbers we had 1, we had 2, but for oxygen we had a 1.5 instead. So we had a 1.5 instead of that. So if you ever get a 1.5, what you have to do is you need to multiply everything by 2. So you go back and multiply everything by 2, because that will get our 0.5 to a whole number and everything else will remain a whole number. Alright, so that's how you come up with empirical formulas. Again, for the first ones, you already have grams, so it's one less thing you need to find. Then for your percents, the ones that use percent, just remember that use that 100 grams. Make your life easier, we got 100 grams of it. Alright, but with that said, you guys are doing awesome. If you have any questions, make sure you email me. And, one important thing, we will have a test Wednesday over net ionic equations and molecular formulas. So, make sure, I think it's predicting reactions, net ionic equations, percent composition, empirical formula, and molecular formula. So make sure you are aware of those topics, and if you need help, now is the time to get them on any of those topics. Alright, but you guys are doing awesome, and I will see you Monday.